This is video 4 of our work with logarithmic functions. So the next page is actually this one with exploration 2, and I've decided that we're going to skip this one for now. It's not really essential to take a look at a log with a base that's less than 1, so I'm just going to skip that for right now. And we're going to go to the last page. All right, so this one is about just transformations of logarithmic functions. So it's just taking that parent function that we've just looked at, looking at y is equal to log base something. And if we look at all of these, we notice that they're all log base 2. So we're going to use that log base 2 of x that we just looked at, that graph. So we're going to treat that as the parent function and just move it around or stretch it or not stretching, but flip or move it horizontally or vertically. So log base 2 of x, remember, look like this. It has an x-intercept of 1 and the y-intercept, or the y-axis, acts as an asymptote. Okay, so the first one, and what we're going to do on all of these is just draw a rough sketch. So rough meaning it has to have the correct shape and position. And then we're going to include and label the asymptote and then the new location of the x-intercept, all right? So it used to be at 1, 0, where is it now? That's what we want in each of these problems. So the log base 2 of x minus 4, the minus 4 that's kind of stuck out here at the end, remember, means that you move everything down 4 units. So if I take this function, the parent function, and move it down 4 units, notice that this is a vertical line, and if I move it down, it doesn't change it. And so that means that my new graph is going to have the same asymptote. So this is the line x equals 0. But what used to be at 1, 0, when I move things up and down, I'm changing the y values. And so I'm going to subtract 4 from that, from the y value. And so I end up with 1, negative 4. Right? It used to be at 1, 0. Now it's at 1, negative 4. It's negative. And then, so the graph, it will still have this as an asymptote, and it's going to go like this. All right, the next one, what you might want to do is turn off your camera and go ahead and try that one on your own, and then turn it back on again and see what I've done. So this one is just going to move the graph up 3 units. So here's our parent function, plus 3. So just like before, if I'm moving it vertically, it's not going to change this asymptote. So that's still going to be the asymptote at x equals 0. This point right here, just like everything else, is going to move up 3 units. So what I'm doing is I'm adding 3 onto the y coordinates. So that's going to give me the 0.13, just estimating where that is. And the graph is going to look like that. The next one, the next two, notice that these are inside changes, all right, x plus 2 and x minus 5, and so that means it's going to move it horizontally. This one meaning that it moves to the left 2. So going back to our axes, right? Now this time, the parent function has, of course, the asymptote here. That's going to move to the left 2 units. So now the asymptote is going to be x equals negative 2. Now if I'm moving to the left and right, like this, the x-axis moves left and right. Now I'm changing the x values. So if I'm moving the 0.102 to the left, I'm subtracting 2, I end up with negative 1, 0. That's going to be negative 1, and then the graph is going to look like this. So again, it's just that same shape, just moved over to the left 2. And notice that, remember, in the original function, this point is 1 unit from the asymptote. Same thing here. Notice that that's 1 unit from the asymptote. It's another way to come up with that. So for number 4, again, what you might want to do is just try it on your own. Turn off the camera or turn off the video and take a look at it yourself, and then come back and watch me do it. All right, so for this one, the x minus 5, we're going to move 5 to the right. So again, going back to this parent function, here's where the asymptote used to be. It moves to the right 5 units. So now it's here. And we know that the point of intersection is 1 point over here, so that's going to be a 6. Another way to think about it is to take the 1 and add 5 to it. Okay, moving 5 to the right again means you're changing the x coordinates. So what used to be 1, 0 is now 6, 0. So there's the graph of this one. Okay. Another thing that I didn't ask, that it doesn't say in writing to do, but I'm going to ask you to do this, is to do the domain and the range. So let's go back and pick that up for these. So the domain for this first one is just like the domain for the parent function. It's going to be 0 to infinity. We saw that on the first page looking at that. And the range is going to be negative infinity to infinity. For number 2, same thing, all right? Same domain, still is from 0 to infinity, range is the same. So it's the same for both of these. For the next one, though, the domain changes, doesn't it? Because the x values go down to negative 2, but not including it. So the domain is negative 2 to infinity. And then the range is negative infinity to infinity. And then over here, this time the domain doesn't start until 5, so 5 to infinity, range negative infinity to infinity. I'm going to stop here for this video, and we're going to finish up the last few problems on the last